Good evening. I really hope you guys enjoy listening to this and also watching this for those of you that are on YouTube. The reason I'm making this video is really to share my bull case for why I believe Rocket Lab, which is my number one conviction stock, is going to be a barn burner over the next 10 years, and why I think it's going to do extremely well and has the opportunity to, at least in the next 10 years, 5x potential, but I think in the longer term, 20x or even potentially 50x in the longer term. There's a lot of different ways that I could go and start off on this particular potential discussion about everything that Rocket Lab does. But what I think you need to recognize, and initially what I did not recognize when I invested in Vector Acquisition Group back in 2021, is that Rocket Lab specifically, while it's called Rocket Lab, is not necessarily specific towards only launch. And what you'll recognize as you dive into some of the numbers, which we're not really going to do too much today. I might pull some off the cuff, or maybe I'll end up diving into it. I don't necessarily know. Depends how long this video goes. But really, the biggest reason that I initially invested in the company was it's called Rocket Lab. It's obviously about rockets and launching into space. What you soon recognize is that the company is more about space systems and being able to put constellations up into space and truly be an end-to-end space company. Now, what does end-to-end mean? Is basically you call them up. If you have zero space experience, you can call up Rocket Lab and say, hey, I want this delivered in this time frame. Can you get it done? And they'll probably say, yeah, I mean, everything's going to come at a cost, but they'll be able to make you the satellite from scratch, be able to launch that satellite, be able to operate that satellite, as well as give you the data from that satellite without you having to lift a finger. That's unlike many other space companies in the past, where you've had to potentially collaborate with NASA or whomever to be able to get whatever you want up into space. And now it's very hands off, right? And so with that, I think there's going to be a lot of growing total addressable market coming into the future as more and more folks rely on geospatial data as well as communications data reliant from satellites in space. And so initially that first piece is, it's not just a launch company, it's an actual end-to-end space company that deals with a lot of different things. So we're going to go through the most obvious, which is the rockets that they actually launch into space, but we'll touch a little bit about some of the components and as well as ready-made or built to suit spacecraft that they have on deck, to the point where now they have 4 very consistent, but it looks like they're growing another 2 to 3 behind the scenes that are specialized for specific cases. Whether or not those develop into their own sort of prolonged sort of satellites, as we've kind of seen with some of the others that we'll get into today, like Explorer and Photon, etc. We'll see if those become more standardized and built for the longer term, specifically for like the Space Development Agency contracts and stuff of the like. But yes. So let's get us kicked off specifically around what probably most of us got invested into Rocket Lab for, and that's particularly the Electron rocket. Now, for those of you that don't necessarily know too much about Electron, it's the second most launched vehicle in the United States, which might come to a surprise, and that's behind the SpaceX Falcon 9. So a lot of you guys know SpaceX Falcon 9. It launches once or twice a week at this point. They're doing a really good job with respect to their cadence. But Electron, even though it's so far behind in terms of the amount of launches per annum, Electron is the second most launched vehicle in the United States, and is also now, as of this year, become the third most launched vehicle worldwide to go to low Earth orbit. So in that respect, pretty admirable. And believe it or not, I'll get to a slide later on that shows that Electron was actually the fastest vehicle rather, to get to 50 launches to low Earth orbit, faster than the Falcon 9 even. And some of you might say, well, it's apples to oranges. Falcon 9's medium launch. This is small launch. And you could say that if you wish. But regardless, cadence is cadence. And I think it just demonstrates a good opportunity. So hopping into Electron. So what is it specifically? 52 launches to date, 192 satellites. The hope is that eventually it becomes a reusable type rocket if they are able to take from the sea landings and be able to refurbish them and launch them. They have 3 different dedicated sites. They have one in Virginia, which they've launched from since 2013 timeframe, and they have 2 launch pads in New Zealand in the Mahia Peninsula. So the reason why they created this vehicle was to be able to have a smaller lift capability. So at the moment, you can kind of see it's about 300 kilogram to low Earth orbit. This has actually come up a little bit, closer to 700 pounds, if I'm not mistaken. But you can see it's 2-stage. It's 1.2 meters wide, 18 meters tall, so just under 60 feet. Loses liquid oxygen and kerosene for its propellant, and it's mostly 3D printed composite structure, so it's pretty cool. The engines that it uses, you'll see here, there's Rutherford engines here, 9 Rutherford engines here on the bottom, and then the second stage uses what is a single Rutherford engine, which we'll see in a second, and then the kick stage is using a Curie engine. So let's get a little bit into the Rutherford engine. So first stage, as we alluded to, uses 9 Rutherford sea level engines, so provides 190 kilonewtons of thrust, or 43,000 pound-feet. And then you have the second stage, which uses a little bit less in terms of the total amount of thrust, but it's a vacuum Rutherford engine that basically is used for the second stage. Reusability, they used to try to capture these with a helicopter. They've stopped that now. Now they're basically just grabbing them to be able to recover them from sea landings. So that's what this parachute is for. They're able to get a barge out there and pick it up. There's also the Curie engine, which is used at the kick stage. You might not necessarily refer to it in here, but yeah, it'll basically allow you to get really good precision associated with your Electron satellite deployment. I might as well just bring this up right now. So we talked a little bit about the 50 launches faster than any commercially developed rocket in history. You can see Electron here in red, with the purple here being the Falcon 9. So you can see it's slightly ahead in terms of this. You can see Falcon 9 really starts to inch up after 6 years. But right now at 50, all we need is 16 launches over the next several years to be able to beat the Falcon 9. It took them 10 years to get to 100 launches. So here we are. So we basically need 16 launches per annum between now and 2028, I think, to be able to get to 100 launches prior to the Falcon 9, or just in pace with the Falcon 9. So if we're able to exceed, get 20, 25 launches in a particular year over the next few years, then we'll be set. One of the things I'm curious about, though, is if this will include Haste launches, because that obviously is designed slightly differently. So I'm curious if eventually we actually have a Haste competitor on here as well. So you have Electron, then you have Haste, which I anticipate once Haste gets fully up and running, that'll be a monster, because we have 4 clients for that at the moment. We'll start to see Haste competition get really aggressive, I anticipate, in the 2025-2026 timeframe. I think another thing that is really, really admirable about the Electron rocket is its accuracy, in terms of being really well aligned with apogee as well as perigee. And I think if you were to think about this, you're launching something into orbit from thousands of kilometers away, basically. Once you get to orbit, and once you're circling around the Earth at a certain point, you're basically trying to get into a certain orbit around the Earth. So with that, this is the accuracy. These red dots demonstrate, how accurate it is within a 300-meter circle from a perigee as well as an apogee perspective. And you can see specifically for this 50th launch, it was 8 meters off in the apogee and 3 meters off from target in the perigee. So very good accuracy in that respect. And so you can see this is part of the reason why some people might give people crap, or Rocket Lab crap, about how well done and how much effort they put into each one of these particular launches. And some people have given them crap about making Ferraris in terms of rockets, but you get results like this. And so you might start off slower building something like this, and it might be a little bit more expensive, but at least you're getting to orbit, right? You have a very good high success rate, over 90 something percent. You have very few failures. And with that, you can really guarantee that your payload is actually going to get to orbit in a way and an accuracy that you want it to, versus getting it done cheaply, might not necessarily be the right way to get it done. So, like I said, margin for deployment is typically 15 kilometers, and you're getting within 8 meters. So that's pretty impressive in that respect. So moving on to another piece of why Rocket Lab is another great thing to potentially look at, the spacecraft part. So you have a family of different configurable spacecraft that they've been able to build. They do it rather well. They have a bunch of different spacecraft in the backlog, and you can basically, like we stated earlier, design your mission however you want, figure out what kind of components you need, and they'll build it for you, right? And so much so that when they've designed some of these things, they've built one, they've done a really good job about putting a lot of these things into orbit, and then recognize that they can reuse these for particular types of missions. So this Explorer is specifically for interplanetary. Then you talk about specifics around the Lightning, which is the bus for high power, long life missions. So that might be specific in low Earth orbit rather than going interplanetary like the Explorer. And you can see some of the missions that are associated with that. Then you might have Pioneer, which specifically is a re-entry capsule, which was tested out with Varda, which basically put up a lab into space, if that makes sense. Let's see if it has like a quick, so they basically were able to put in processing phase for Varda's mission, hypersonic re-entry capsule carrying temperature-controlled pharmaceuticals on board for a return entry. So they launched it in June 23, and it came back in February 24. And there's going to be a potential fifth vehicle in development for another customer. And I know Varda has a second launch and third launch planned as well with Rocket Lab, and I actually think that they're also going to do some things with SpaceX as well to see how that works. So that's the Pioneer vessel, and that could be used for semiconductors. It could be used for pharmaceutical experiments, medical experiments, etc. You have Photon, which was kind of the original spacecraft that Rocket Lab had kind of advertised, and an integrated launch plus spacecraft solution, modified Electron kick stage with power propulsion, communications to low Earth orbit that provides civil, defense, commercial, and a range of different types of missions. So it's 200 to 300 kilograms. And they're actually going to try to use this as kind of a tank for cryogenic fuel demonstration for, what is it, ETA? Yeah, the ETA mission, which basically what they're saying for this is they're going to make it like a capsule that can store cryogenic fuel for fuel ups. So whether or not they launch these ahead of, say, some of the Mars missions that might be happening in the future, or for Artemis or something like that, they're going to actually be able to refuel mid-flight. It might allow you to have smaller vehicles, and then if you have cryogenic fuel depots along the way, you might be able to fuel up rather than specifically having such a large vehicle. I don't know, just some food for thoughts there, right? So they're going to test this for liquid oxygen storage and other critical fluid management data while in orbit in the coming mission associated with that. So that'll be really fun. Going back to specifically the Lightning. So the Lightning, there's two big contracts currently ongoing that are actually being delivered. One's being delivered right now, and one is to be delivered through the Space Development Agency. So you have Global Star Communications, which is Apple reached out through MDA, which is a Canadian company that then subcontracted out to Rocket Lab to create these Global Star spacecraft buses. And so these are being delivered to Apple at the moment, and I think with that, you'll see other customers potentially reach out specific for this. Then you also have the Space Development Agency Tranche 2 layer, transport specifically, and also the beta layer. And they were the prime contractor for this, so a step up to basically be the lead contractor for a $515 million contract. And this provides 18 satellites for the Tranche 2, which is supposed to be, I think, launched from 2027 to 2029. And so there's potential that there's other contracts they might win from the Space Development Agency, just knowing that there's literally going to be thousands of additional satellites across the entire Space Development Agency constellation that's being built. Not only that, but we'll get into this in a little bit, but with these satellites that they're building, somebody has to launch them as well. And so there has not necessarily been, and correct me wrong if I'm wrong in the comments, a direct line as to who's specifically going to launch a lot of these satellites as of yet. So with that, the hope is with Neutron, which is their medium launch vehicle, which I'll introduce to you guys in a moment, that is still up for grabs because that will potentially be available starting mid-2025. So that might be the basically launch provider for these satellites into space from 2027 to 2029, which is when they're anticipated to be delivered. And then the Explorer is pretty cool. So for the interplanetary spacecraft, for those that are listening online, this was kind of kicked off specifically for the Capstone mission to the moon, as we re-explore with Artemis going back to the moon to eventually go back to, or not go back to, but kickstart the opportunity for NASA and others to go to Mars. And so this was deployed in 2022. And then you also have future missions specifically for Escapade, which was supposed to go to Mars on a Blue Origin rocket later this year, but that's been delayed to the first half of 2025, first quarter more specifically for 2025. So we'll see how that goes. And that's a collaboration with University of Cal Berkeley. And then you have the Venus Lifefinder mission, which is actually pretty cool because it's like one of the first private Venus missions out there. Obviously, you have some missions for Venus funded through other means like NASA and stuff of the like, but this will be the first time from a private perspective that somebody is trying to attempt to go to Venus. So that'll be really fun, and we'll see what type of potential for life there was on Venus. So that explains Electron. That explains the off-the-shelf ready spacecraft. But I think what a lot of people neglect as well, some people recognize this, some people don't, is within the space systems piece of the company, which is 2/3 of the revenue at the moment, and hopefully 250, potentially growing into 300 million over the next 12 months in terms of revenue. And eventually, hopefully 400, 450 once you get into 2025, 2026. You have the ready-made spacecraft, or the ready-to-order, I guess you could say, off-the-shelf designs. Obviously, there's going to be parts of that that are customizable, but you kind of have that main frame of what kind of structure you're looking for and what kind of frame you're looking for. And then you can have some customization piece to it. But you can order specific systems, right? So back in 2021, 2022, Rocket Lab made a series of acquisitions for smaller companies that were bolt-on opportunities that allowed them to, let me just show you this list here, basically create radios, space software, separation systems, solar solutions, composite structures. And so we'll just go through a few of them right now. So the Star Trackers piece was something that was kind of a limitation back in the day. It was a small shop, if I remember correctly. They bought it out and basically were able to increase the cadence. So in 2020, they purchased this one as a bolt-on acquisition. And so since then, they've been able to increase the amount of total output for Star Trackers. So they offer high performance, affordable, rapid response spacecraft components for small satellites, one-off or interplanetary missions. So it allows you to kind of see what you're doing. So Star Trackers here on the left can kind of be baffles for small spacecraft, and then you also have the reaction wheels here to basically be put into a range of different opportunities. So there's that piece. So this is some heritage actually. So this is kind of cool. So Sinclair Interplanetary and Rocket Lab Design built flight hardware for the following missions: GHGSat, which was in May 2022, MATS, Black Sky Global, that was in 2022. And you have a whole bunch of things going back. That's pretty cool. Let's see what kind of heritage we can get all the way back. So lots of different things. A lot of black sky in here. More black sky all the way back in 2019. Wow, way back. 2017 even. 2016. 2015. So this has a long history. And so this was a good bolt-on acquisition. They've actually been able to increase the reaction wheels output, which I think is a big piece that I think was, like I stated, at a pretty big capacity constraint for this particular thing, necessary for a lot of vehicles out there. So Rocket Lab is now an owner in that game. The software radios here, so there's Frontier S, Frontier X. I actually haven't done too much digging into these. This is pretty cool, but allows you to do telemetry tracking and command band communications for deep space. So this is pretty cool. Not as much details, but they do have the data sheets in here if you guys are interested in going in a little bit more into the detail. But key features: geo, deep space radiation tolerances, high reliability. You can kind of see the actual build themselves and what's actually being in here, the power, wavelength, etc. That's pretty cool. Then you can do, that's the S. What about the X? I'm assuming that there's some sort of main difference between the two, which at the moment, high speed X-band software, defined telemetry tracking versus the S, single board, got it, software defined telemetry. So it seems like the X seems a little bit more defined and a little bit more complex. Interesting. High data rate versus this looks like it's a slower component. But I don't know much about the radio pieces, to be very frank with you guys. Space System is an interesting one because they are, wow, this is kind of cool, this tracker. 237 years of max flight software. So this was provided by ASI, so Advanced Solutions, Inc. October 2021 is another bolt-on acquisition. And this is actually kind of cool because I believe, if I remember correctly, that this is going to help with the Blue Ghost lander, if I remember correctly, that is going up into space. 50 successful missions, 185 years cumulative in orbit. You can see it's still counting, which is kind of cool. How much does it do a second? So it was 12 minutes. Now it's 14 minutes. Okay, so it's counting pretty quick. What's the max portal? Let's check this out. So software systems is a nice piece. A lot of separate material into this max software stuff. Oh, wow. That's pretty cool. You can see what I'm basically, for those that are listening, the max flight software orbit, and it was showing like all the different types of orbits that are being done right now. So that's pretty dope. So yeah, I'm trying to remember. Actually, while I have this open, let me look at upcoming missions. I'm curious. I think the Blue Ghost mission is being powered by ASI. So let's see. So this is Blue Ghost, which is Firefly's lunar lander. So Solero is providing the solar panels to power Blue Ghost. And then ASI, yeah, just the software like I was just talking about, it's providing the flight software for ground, GNC, trajectory, orbit determination, avionics. And it's also hosting the backup mission ops center. That's pretty cool. So yeah, Blue Ghost is developed by Firefly. The hope is to deliver 10 payloads to moon surface. So that'll be interesting. Hopefully, and I don't think it's going to be on par for this year. Maybe it is. It's been a minute since I've looked at it, but hopefully 2025. Then you have separation systems. I think that they just updated some of these separation systems as well, if I remember correctly. Yeah, they just had like the satellite dispenser that they just updated, sub-assemblies and accessories, and they have motorized light bands, advanced light bands. So they build separation systems because they don't compromise on proving reliability. They have a history of innovation followed by intense and rewarding engineering to prove reliability. By this method, we contribute our best work. So this is a company that's dating back to 1998. Separation systems have enabled customers to lower their mission costs and streamline payload integration. So advanced light band is the next generation in space vehicle separation systems, increasing performance, decreasing lead time. And then they just have this canisterized satellite dispenser that provides reliable and cost-effective housing for CubeSat payloads, minimizes risk, damage risk, and eliminates necessity for heavy, complicated interfacial structures. So that's necessary. Like that's a whole thing that obviously you need to have separation systems within your satellites and your rockets to be able to get them into orbit, right? You don't want to have this excess stage 2 just hanging on to your satellite and weighing it down, right? Just extra drag that you don't necessarily need. And I'd say the one that's most probably recognizable for folks is the space and solar solutions that people really gravitate towards. So Solero was a 2022 acquisition, and this has powered a lot of different satellites. So to go into some of the details, up to 34% efficiency. So it's some of the best in terms of efficiency that it's out there. And it's super, super thin. Obviously, weight is a big problem when you go into space. So any weight that you're adding in terms of the solar system, that's solar power that's on the satellite itself is going to weigh down the whole rocket. And with that, you're going to have a smaller payload. So having a very effective and highly efficient solar panel, 34%, which is really efficient, really helps out from that respect to lower total weight. So specifically satellites like CubeSat and small sats and constellations is looking like the concentration. They've had some recent, I was curious to see if they were going to provide any recent missions, but I know specifically the Psyche mission, which was a NASA mission to go towards an asteroid in between Mars and Jupiter. That was launched by SpaceX not too long ago, and that was powered by Solero solar panels. But you can see specifically their manufacturing, automated assemblies, composite products, panel manufacturing, acceptance testing, R&D, and product development, all since 2022 during the acquisition. So I think this is one of the key things because obviously batteries are very heavy and obviously deplete. And so with solar, you're obviously, once you're in space, getting a lot more solar energy coming directly from the sun, and allows you to power up your satellite. So this, I think, was genius because then you can kind of be integrated vertically and not necessarily have to rely on somebody else for solar panels. So that way you have your own self to rely on. Then you have carbon structures that they're potentially building. So this is an example, it looks like, of the Neutron, one of the Neutron tanks. Then you have the Electron here being built. This looks like a space satellite. So a bunch of different reasons. So you can see the big ass printers that they have here. They've displayed this in many different areas. So 7 autoclaves, 5 ovens, 5 ply cutters, test equipment, 10 machining centers, and assembly. Lots of talent, lots of products that they're able to create. So composite tanks, custom projects, satellite buses, primary structures, solar panel substrates. Um, Different production locations. So they have Baltimore, Middle River, USA, Albuquerque, New Mexico, Auckland, and Warkworth. So that's the space systems business. That's about 2/3 of the revenue of the company at the moment. That's growing relatively well. 30% gross margins at about, based off of what we're kind of seeing coming from the earnings reports. And so hopefully it continues to climb. There's some legacy contracts, as you heard. Some of these things were acquired in 2020, 2021, 2022. And so they have some legacy contracts to fulfill for some people. But once those legacy contracts are fulfilled and they go to renew, they're likely able to, specifically considering you're having more and more consolidation in the industry, the ability to raise your margins from a gross basis, which will hopefully continue at a net basis. So, believe it or not, just Electron and space systems, from what we've heard from Peter Beck and what we've heard from Adam during the conference calls, these are actually profitable businesses at the moment. And if you were to eliminate the drag of the Neutron rocket, which we'll talk about in just a second, it actually would be a profitable business. You'd be EBITDA positive. But unfortunately, because you have this R&D piece coming in from Neutron, which is a $300 million expenditure, you're burning cash, unfortunately. So there's that piece. But speaking of cash, before I get into Neutron, the company has a very significant cash position. $550 million on hand as of the end of 2Q. Some of that came at the mercy of doing a capital raise in the earlier half of this year. And so that capital raise was to pay off $100 million in debt that was due in June or July of 2024. And so with that, so that's fully cleared off. And now you don't necessarily have to worry about that piece. Now you have $550 million in cash to be able to use for acquisitions, further investments into the company. So we'll potentially see what happens with that. I anticipate that cash will be, as they said, used for acquisitions, but it doesn't necessarily say whether that's going to be existing companies, bankrupt companies, and we know that in the past, RKLB has acquired companies for pennies on the dollar, more specifically Virgin Orbit's facilities in Long Beach, California, for what it seemed like 16 cents on the dollar. They acquired $16 million worth of equipment and facilities, and I think they were valued at close to $100 million. So that's allowed them to expand their capacity for a lot of these things that we're talking about, from an Electron, space systems, Neutron perspective. Not exactly too sure what the Long Beach factory was specific for, but I know it had a lot of equipment, which I think was a lot of it was like 3D printing and stuff like the like. But I should do a little bit more research into that. But just know that they're waiting, right? They're in a very good cash position, unlike a lot of these other competitors, Astra namely, and a few others that are really struggling as we get into the second half of this year. So they're either cutting down in terms of staff, decreasing revenue in order to get there, just to kind of get to a place where they're stopping the cash burn. And so unfortunately, that means they're giving up market share. And do you really want to be doing that right now when everything in space is kind of growing at a pretty decent pace? So going into Neutron is going to be the answer to the Falcon 9. From a Rocket Lab perspective, there's no real good competitor, in my opinion, to the Falcon 9. You could say that New Glenn from Blue Origin is a competitor. But to me, that's more of a heavy launch. That's more of a competitor for the Vulcan rocket from ULA. And so I'm very curious to see who else comes out with a medium launch rocket. There's other competitors out there. Relativity is creating the Terran R. They launched the Terran 1, I think it was in 2020 or 2021, and had a near successful first launch. They immediately said, we're going for medium launch. We're no longer going to do small launch, which is understandable, right? If you could do a medium launch vehicle, put a lot of R&D into the medium launch vehicle, you get more bang for your buck, right? You're talking $50 to $100 million per launch at this point, depending on the capability and lift capacity. And so at this point, it makes more sense potentially because small launch, you might be getting 5 to 10 million, maybe 15, depending on how large the vehicle is. So if you design one, maybe it's better to design something. If the market and value is there to design a bigger vehicle, you get more money per launch, right? So we'll see what ends up happening with that. That said, Electron's done a phenomenal job growing from $6-7 million per launch to the high $8 million per launch, and sometimes with Haste, you'll even see it go north of 10 million due to some of the capacity and not capacity criteria that they specifically want for some of those launches. So Neutron at the moment doesn't have any contracts per se, but there's a lot of interest from what Peter Beck has said. So from many conversations, myself included, after the 2Q earnings call, he also said it after the 1Q earnings call. We had a great conversation with him, and many other interviews that I've seen him say. He says there's a lot of things he's concerned about with Rocket Lab, risks, etc. The demand for Neutron is not one of them. So obviously getting the rocket up into space is probably something he's concerned about, but he knows the demand is there, right? I'm sure he's had a lot of conversations with folks. A lot of people want to potentially get deals done, but I think historically, because first launches are iffy, many people are hesitant to, do any business on the first launch because of how risky it is, and so they're asking for some sort of discount, 4 to 5 launches at once at a discount. And Peter Beck just says, F it, we'll eat it. We'll eat the cost of the first launch. We have the cash on hand to be able to do that. And once we prove the capability of Neutron, and hopefully they get it right on the first try, which will be phenomenal. And if they do, they're open for business, right? And people want to pay $55-60 million, then they're open for business. But specifically, the hope is that it's reusable from day one. That'll be unlike the Falcon 9, which was retrofitted to be reusable. And they're also going to try to attempt to land it on the first try. They actually won't land it per se, but they're going to do something comparable to what SpaceX has just done with the Starship, which is basically like land it flat on the sea and then just let it like slowly tip over is my assumption. So I don't think that they're going to try to land it on a barge or anything like that. I think they're going to try to like controlled land it on the top of the sea level, and then let it topple over on itself to see how controllable it is, right? Are they even able to get it to a sustained control descent? So 13,000 kilograms to low Earth orbit. To remind you, it's 300 kilograms, 330 kilograms for the Electron rocket. So a much larger volume going into space. And this varies as well, depending on if you want to go downrange, you want to re-land at the pad, you want to expend the rocket and not necessarily reuse it again. There's different lift capabilities, but to be able to land it downrange, 13,000 kilograms to orbit, 15,000 kilograms to Mars or Venus. So we'll see what those potentially have in store. It's about 3 times as tall as the Electron, so 141 feet or 43 meters compared to the 17 or 18 meters for Electron. And it's much larger in diameter, 7 meters in diameter comparatively to the Electron, which I think was like 1 point something meters. Payload, like we stated, to low Earth orbit for 13,000 kilograms. It's about 500,000 kilograms. And this one uses liquid oxygen as well as methane, as opposed to kerosene from the Electron. So it's designed for mega constellation deployment, deep space missions, human spaceflight capability. So they did basically design it to do human spaceflight. At the moment, from the conversations we've had with Peter after the 2Q earnings call, it's capable of human spaceflight. I don't think they're designing a vessel at the moment. They just don't think the TAM is there. So I think that right now they're just focusing on the Neutron itself. Maybe in the future, if the total addressable market's there, they're not ruling it out per se, but they're not focusing on it at the moment. Is kind of the verbiage that we got. But it's nice to see that they basically got it certified for human spaceflight, and it's capable of human spaceflight. Hopefully efficient reusability, return to the launch site, and then captive fairing design allowing free reusability. So Basically, it's sitting in here. So you just have to load up your satellite and put it in here rather than have an expendable, say, second stage or something like that. First stage, 9 Archimedes engines, low liquid oxygen methane oxidizer, about 1.5 million pound-feet of thrust. It's pretty interesting. And then you have the Archimedes engine here, which is about 200,000 pounds of thrust as well. So really cool looking design, if you ask me. So you can see the fairings up here that don't necessarily get expelled. Here you can see it opens up like so. Makes it a little bit easier. This was originally supposed to be 3. They designed it to be 2, which I think is going to be helpful from like a mouth clearance perspective, if that makes sense. And here's where they're at today. So they did the first Archimedes engine hot fire testing. So where are we in terms of the next stages? So currently they're building Launch Complex 3, the stage 1 build, the full-scale composite stage 1 tank, etc. is ongoing. The flight mechanism test programs are ongoing. They have yet to do a static fire, a stage 2. They haven't done a stage 1 static fire, being in the 9 Archimedes engines, final integration, wet dress rehearsal, etc. And the hope is 2025 launch. So I'm curious to see how many milestones we're able to get to from like a stage 2 static fire, a stage 1 static fire, which is the 9 Archimedes engines together, and then the final integration piece. I'm curious to see how much of this we're able to get done in 2025. So the cool thing is they did share within this presentation the hot fire for the Neutron Archimedes engine. You can see it reached 102% throttle, which I guess is 2% more than what they were forecasting to get. So that's pretty cool. There is conspiracies going on right now. Some people have heard that they really only tested it for a couple seconds versus a sustained, let's say, 60 to 300 second sort of test period, which would be able to be the 300 seconds obviously would get it 5 minutes or so into low Earth orbit at that point. So curious if anybody out there can prove that myth. I might reach out on X or something and tweet at Peter to see what's the deal associated with that. But Neutron will be interesting because right now they're planning on 1 launch in 2025, 2 to 3 launches in 2026, and so the cadence is supposed to go up from there. And so my hope is that eventually you end up with at least once per month, or sometimes 2 to 3 times per month, and you get a decent cadence associated with that. You get a 50% gross margin on this, and eventually you're talking about a couple $1 billion in revenue, which leads to closer to $1 billion in net income at the end of the day, inclusive of the Electron, Haste, etc. And we'll get to Haste in a second. And so I think eventually you're just going to have some of these things stack on top of each other and get to $1 billion in net income, in the coming 5-10 years. And there's obviously going to be a multiple on that. And right now we're trading at a $3.5 billion market cap. So basically trading at liquidation value, if you ask me, with all the different systems that they're able to provide. I mean, anybody that's looking to get into the space constellations would be chomping at the bit to be able to buy this company at $3.5 billion with the capability it has. And then imagine once they get the Neutron rocket up and going. Talk about a return on investment, right? I know it's from a sales perspective and not necessarily net income perspective, but you spent $300 million out of pocket to be able to develop a rocket, and you're able to get $55 million per launch. That's really good. You launch 6 times, you basically have gotten your revenue to feed back. Now, of course, that's not net income, right? So there is that piece of it, but talk about a return on investment, right? 300 million to make 60 million, 55 million on a single launch is pretty badass. So I'm curious to see how that works going forward. And then last but not least that I'll stop with is Haste. And Haste stands for Hypersonic Accelerator Suborbital Test Electron. So it's the same sort of body as what we have here with the normal Electron rocket, 18 meters tall, 1.2 meters in diameter. And with that, apologies, it's past midnight here. I just wanted to make sure I get this video out for you guys. So sorry if I'm rubbing my eyes here. This is suborbital, right? So it has pretty much 2x the amount of payload mass capacity, just because you're not necessarily going to orbit. It's suborbital, and you can have custom trajectories, different angles, etc. But it really allows you to have very different types of payloads, whether it's air breathing, whether it's ballistic reentry, gliders, space-based applications that you're testing for. And you can see it's all common Electron in terms of the base. And then there's an interface that has the integration piece of it. But really the only one that looks very different is this boost glider, because it has to be maybe a little bit wider. But you can see with it, there's a lot of different things. This looks like a miniature Varda photon, if you ask me. But we'll see. This might be some sort of missile or something like that. But it kind of looks like. Let's go back to the spacecraft here. It kind of looks like the Photon a little bit. Sorry, Pioneer. Looks a little bit like the Pioneer. Photon's completely different looking. Yeah. So it kind of looks like the Pioneer a little bit, like what Varda had. But anyway. So I think this is interesting. And why specifically do we think that this is actually going to be important? So gets you to some pretty serious altitudes, many different things that you can do with it. You can do a lofted, depressed sort of trajectories. That's pretty cool. At the moment, all of them are going to be launched out of Wallops, but we had discussion with Peter Beck again after the 2Q earnings call, and he said this is something that could be deployed at other locations across the world, whether or not it's specific to US or what have you. But that was one thing that we were kind of looking at. But you can see some of the partners at the moment. Leidos, you can see the Missile Defense Agency, which is part of the Department of Defense, Defense Innovation Unit, which is part of the Department of Defense. So you're starting to see some folks actually get ramped up. And so how much has Haste actually been growing at the moment? There's only been one launch in June 2023 out of Wallops, Virginia. But with that being said, there's several launches upcoming for Haste, one or two within the next 3 to 4 months, as we've seen some recent photos of the backlog and the rockets that are being built in New Zealand. We saw several Haste in there, and with that, our hope is that some of that actually comes to fruition. But you can see in the upcoming missions tab, there's a Haste section within here that really focuses on U.S. Department of Defense DIU, which is the HICAP program, and then they're talking about some other suborbital tests for another customer, Haste for Leidos, which I think was the first customer back in 2023. So it's 4 dedicated missions through 2024 and 2025. So the hope is and I think you have another customer as well that isn't disclosed in here. I think that at the moment there's 4 customers that are spanning from this, and all this is from 2023 to now. And so 18 months later, we're hopefully going to get 4 to 5 additional customers with their first test and Leidos with their second. And with that being occurring, my hope is you increase the cadence, right? And the question is how frequently can you launch this thing, right? And how much does it cost? Well, from right now, it seems like it's anywhere between $8 to $10 million, sometimes more, based off of what we've heard for specific types of launches. And with that, if you think about it, you end up getting 1 or 2 per month. You're increasing the the top line by another $80 to $100 million a year. If you do it twice per month, you're talking another $160 to $200 million a year at a gross margin, hopefully at closer to 50%. You're talking about something hitting the bottom line, getting you potentially a couple $100 million, if not, depending on the cadence, up to $1 billion of additional net income in the long term, right? So you start thinking it's not unfathomable where if you have, let's just say, 5 launches in a particular month, and you do that 12 times, you're talking about 60 launches. you're talking about $600 million in sort of revenue there. Wouldn't be surprising you get 150 to $200 million of net income off of that in the longer term. And if you continue to have more and more cadence, I mean, I'm just kind of curious what the limit is associated with some of these launches that might happen. Um, so there's Haste, and I think Haste is kind of the next leg up in terms of revenue generation from the Electron platform, and I think eventually that'll be a much larger revenue stream from a Department of Defense perspective, as well as just some of these other global governments as well getting involved in the protection of some of these other global governments, and testing out of um, some of these I guess pieces of equipment that they want to test out. Um, Curious to see, right, from the Department of Defense, they're testing out some equipment using Haste, and a lot of other companies, I'm sure, and countries will be getting on board. So I'm curious to see, if they'll all have to be launched out of Wallops for now, or if we get some passes with some great agreements between countries to be able to help each other in this space. So with that, you might have more people like Australia on board, and several others, and we've seen Australia heat up as a uh, as a country interested in the space systems businesses um, over the past several years. I think it might have been Blue Origin or SpaceX actually just applied for an application to be able to potentially launch from Australia. So that's the big bull case, right? So I know it's 50 minutes worth, but I mean, if you're actually interested in the company, it's hopefully gives you a brief overview. Now, where do we see this company going in the near term? Well, obviously the Neutron is kind of mid 2025 launch, and so that's kind of the big next pivot point piece um, of where the stock price might go. That obviously is a $300 million investment. It's been a drag on the company. After that, you have about 2 quarters supposedly after that where you're cleaning things up, and you're really trying to get the cost spend under control. Neutron no longer has a lot of that capital outlay, operating expenditure outlay, R&D outlay, and so you'll end up potentially having profitability within the two quarters after that. So we're talking about the next 18 months, basically getting towards profitability. And once that happens, I anticipate this thing's going to move pretty quickly, because I think the revenue is going to start coming in. Electron cadence is going to be there. Space Systems cadence is still growing. I think they're going to grow 30% next year, so they're going to make about 250 to $300 million this year. They're going to make closer to $400 next year, maybe closer to 450, on top of increased Electron cadence. Fingers crossed with that. And then on top of that, hopefully maybe one or two contracts coming in for Neutron, maybe a second launch at the second half of the year. We'll see. All right, that's $50 million in the door. So I wouldn't be surprised if we get close to $600 million in 2025, $650 million. And then the year after that, I wouldn't be surprised if we break 800 million, 750 to 800 million. And by that point, 2026, you should start to see some net income. And so then that poses the point, is how quickly can they continue the Neutron cadence, the space systems cadence, all these other things that'll contribute to the bottom line. And once that kind of happens, you'll likely see, net income start to jump up into the couple $100 million range by the time we get to the 2030 time period. So if you start thinking about that, let's just say it's $250 million in net income. 250. Why is my numbers not working? 250. There you go. Well, let's times that, because it's a space company and everything the like. Even a 20 times multiple, which I think is kind of light in that respect. But that should be a $5 billion company. We're not near that today. But let's just say, really, by the end of the decade, we're at 1.2 billion in sales total. I anticipate that this company really should trade at anywhere between a 10 to 20x multiple for price to sales. just based off of how it's going to continue to grow, its niche market, it being a premium company. And for example, SpaceX trades at a 30x price to sales, but let's just be conservative and just say 10x price to sales. And I think you can get close to $1 billion by 2030. Should be a $12 billion company. Right now, we're at about 3.3, 3.5 billion. So right now, you're going to get a 250% return on your money. So let's just say the 12 minus the 3.5, that's 8.5x. Divide that by 3.5, it's a 240% return. So we're talking about in the next 5 to 10 years, easily a 2x return. Easily in the next 5 to 10 years. To me, I think there's going to be a larger revenue stream coming through that I think people really give credit for. There's a piece that I didn't really touch on, which is their own constellation, which it's hard to kind of talk about because they haven't really given too much detail. They're holding the cards close to their chest, understandably. They don't want others to really get after it and take a lot of their ideas. But with the medium launch Neutron vehicle, they plan to launch 50% their own constellation, 50% for other customers. And obviously, that's kind of a pie in the sky, sort of 50,000 foot view right now. They stated bluntly when I asked Adam after the 2Q earnings, I said, well, have you guys done like a cost benefit analysis? What if it's more beneficial to launch, somebody else's? He's like, if it's better for somebody else to get launched and the cost benefit analysis is better to launch somebody else's vehicle, we're going to launch somebody else's vehicle. But he's like, it's nice to be able to have that capability that instead of just sitting around waiting for customers, because we know that what happens on Electron a lot of times is things get delayed. And they're waiting on the customers to be able to provide, or the clients to be able to provide the satellite and payload for them to actually launch. They're sitting around waiting. And if that's the case, they can launch, their own vehicle, which I think is pretty cool in that respect. So in that case, you're never really waiting. You're basically launching something as soon as you have it, right? So if you're able to develop 2 neutrons in a particular month, one of them might be for a client, one of them might be for another client that's a couple months from now with reusability. You might be able to launch your own satellite, start generating more and more revenue. So, I think that $1.2 billion revenue number is really conservative. You start thinking about some of the revenues they may be able to get from their own constellation starting in 2026 through 2029. But we'll see. And this is not necessarily even taking into consideration additional Space Development Agency contracts. But the thing is right now is they're at about a $400 million a year run rate, and they have $1 billion backlog. So the hope is, that backlog continues to grow out in time. And my hope is you've already started to see return customers like Synspective come through. My hope is that you'll see Varda come through with additional contracts. Black Sky, they have a few launches that are going through in the coming 6 to 12 months. And hopefully after those get done, they sign up for a bigger 10, 20 contract sort of deal. My hope is with Haste, you see a little bit more consistency in the long-term contracts associated with that. And I'm very curious, at the end of last year, Q3 last year, which I believe came in November, so at the end of 2023, but they basically forecasted the 2024 manifest. And so my hope is with 2025, you see a lot more Haste missions on there. At the moment, we really can only account for, 4 or so launches within the next 6 to 12 months for Haste for the 4 or so different clients that they have. My hope is the second half, even the second quarter, because all I've really been able to see is 4Q of 24 and 1Q of 25 for those 4 potential launches. My hope is 2 through 4th quarter have much more Haste launches coming through. But let's just see and check in the next couple of weeks where we end up getting to. We're going to have a launch here in the next couple of weeks for September, and that'll be, I think, the last launch for the 3rd quarter, believe it or not, because we're about to enter the 4th quarter of the year in about a month and a half, in about 3 weeks. And we'll see where we get to. The next three months will be very interesting with respect to Neutron and what milestones we're able to achieve. But it'll be not too far from then, 2.5 months or so, we'll get or maybe a month and a half or so, we'll get the the third quarter earnings report and be able to get a little bit more details as to how 2025 revenue is potentially shaping up. So anyway, y'all, been going for about an hour. I really hope this is useful for you guys. Hopefully be able to upload this and do some timestamps. But hopefully for those of you that are listening, working out or anything like that, that's somebody that reached out to me was, hey, I work out in the morning so I can listen to these podcasts and listen to these live streams, but I can't watch them. Would you be able to record something? So hopefully I did a decent enough job describing what's going on and not just saying this or that. I'm actually verbalizing it, and hopefully you guys were able to get a little bit of enjoyment. For anybody that's still listening after an hour, please share with friends and family, specifically around this opportunity with RKLB. I think for me, it's my biggest conviction stock. I have almost 100,000 invested into it, hoping to get to 25,000 shares. I'm at 19,500 shares right now, at a $6. That's a good point. Now it's $6.60. I got to check if it's my number one individual stock. I got to check because it was competing with Palantir, but Palantir is at $35 now. So it's a pretty good return for me right now as well with Palantir. So it'll be fun the next 5-10 years competing both of these, Palantir and RKLB. RKLB will have its volatility for sure, but I have a feeling that my price target at $15 by the end of 2025 will do really well. So thank you all for listening the last hour. Really hope this was valuable, and let me know if you have any comments or if I messed up anything in the comment section down below. I respect criticism. So you guys rock, and I'll talk to you guys soon, and see you guys on the next video. Cheers.